Hi, this is Alan Tribble. I thought I'd give you an introduction to my Space Environment Effects class. On the slides that follow, I'm going to give you a brief overview of what Space Environment Effects is all about and talk you through some of the technical and non-technical details. Hope you enjoy it. The first thing to define is what space environment effects really means. It simply means the effect of the space environment on spacecraft systems. People who study space environment effects study first and foremost the space environment. How do you describe it? What are the parameters that are used to characterize it? How does it change? Secondly, what does that environment do to the various spacecraft systems? For example, the electrical power systems and solar arrays, how are they affected? And last but not least, and in many cases, most importantly, we want to understand techniques to mitigate the effects of the space environment. That entire field is sometimes called space weather effects because the environment in space is not constant but changes just like the weather on Earth. So space environment effects, space weather effects, all of that is the subject of this course. So before we go further, let's make sure we understand why we study the field of space environment effects. And quite simply, it's because history shows us that about 20% of all the spacecraft that make it into orbit suffer some sort of operational mishap as a result of the environment. Some sort of anomaly that we have to spend time resolving and debugging, or even an on-orbit failure of the spacecraft, a subsystem, or a mission. So if we can solve this problem, if we can develop mitigation techniques to make that less likely, we'll be making a much more efficient use of our resources. That's the reason we study this field. Let's first off define the different categories of study before we get into the details. First and foremost, we're going to talk about the vacuum environment and its effect on spacecraft systems. And by that I mean things that happen because we're in a near perfect vacuum. It's not a perfect vacuum, there's still stuff out there, but because we're in a near perfect vacuum, we'll have to deal with certain interactions that we're not used to seeing on the surface of the Earth. The second category is neutral environment effects. Things that happen due to interactions with the neutral, that is the electrically neutral or uncharged particles that are out there. Aerodynamic drag is going to be the first and foremost one of those that we'll talk about. These are the uncharged electrically neutral particles. Third category, plasma environment effects, refers to those lower energy charged particles. The plasma, we'll define that when we get into the details, but we're going to have interactions with lower energy charged particles. And by lower energy, I'm typically talking kilovolt energies. That could charge surfaces to kilovolts, thousands of volts, and spacecraft charging is that entire big concern from that field of study. In some cases, we'll see that you could get charging to even higher potentials than that, but plasma environment effects are the third category. As we move up in energy, we're going to get into radiation environment effects, and those are the interactions with particles that are more highly energetic, MeV or GeV energy particles. They can go right through the surface. Much of the neutral and the plasma particles will stop on the surface of the material. A GeV energy particles are so energetic they'll probably pass completely through the spacecraft, but as they do that, they're going to deposit energy, and there's a whole category of effects that we'll talk about called radiation effects that are the result of those particles. Last but not least, then we have micrometeoroids and orbital debris. These are things that happen due to collisions with the larger particles of matter. And by that I mean particles that are big enough for you to see with your naked eye. These could still be very small, grain of sand type particles, or they could be very large particles, BB sized, baseball sized, larger than that. The concern is because you're moving at such a high velocity. Spacecraft orbital speeds are about 8 kilometers per second. Look at how much energy is available for a collision at those speeds, and it doesn't take much mass to have a lot of energy released. So we're going to talk specifically about those larger particles and their concern for what happens when you run into them. If you're looking for a good non-technical book that can walk you through a summary of the effects we've just been discussing, I would suggest this one here, A Tribble's Guide to Space. Pleased to have Buzz Aldrin write a little blurb for that, as you'll see on the cover. One of the chapters of this book is dedicated to space environment effects. There are other chapters about getting to space and the challenges involved there. Also, why you even need to go to space in the first place. And so I would direct you to that book if you'd like a good non-technical overview. That book you can get directly from the press, Amazon, or your favorite bookstore. If you'd like a more technical analysis of the topics we've discussed, I'd refer you to my textbook that I wrote on this topic called The Space Environment Implications for Spacecraft Design. This is in the second edition, also published by Princeton University Press. You may have an opportunity to take a course taught with that as the textbook, as I'll talk about in just a second, but you can order it directly from the press, again, Amazon or your favorite bookstore. From time to time, I teach a 2-day professional development course on this topic. As you'll see, the schedule here spends the first day going through the vacuum environment effects, neutral and plasma effects. Spend the morning of the second day doing a deep dive on radiation effects, which is the most general area of concern about this entire field of study. And then finish up in the afternoon of day 2 with discussions of micrometeoroids and orbital debris, as well as some concluding topics. The next class I plan to teach will be offered in late spring 2020. The date is still to be confirmed, but it's going to be offered in the May or June timeframe, and it is going to be offered virtually. Given the COVID-19 pandemic, nobody wants to get on a plane and travel too much these days, so we're going to offer this from the comfort of your own home and be teaching remotely. You can go to my website there, alantribble.com, check the schedule of classes there. It will provide you the exact dates once that's nailed down. If you'd like to talk about scheduling an on-site class at some future time, drop me an email. If you do know you would like to register specifically for this next class, you can contact Deborah Bell at Applied Technology Institute, or ATI. They'll be sponsoring this class, and if you drop Deb an email or give her a call, she'll be glad to work with you on additional detail of how to get registered. Hi, I'm back. Hope you enjoyed the introduction to the field of space environment effects. I've got a longer video that goes into a little more technical depth. If you'd like to get into the gory details of each of the individual effects, please take a look at it. Thanks for watching.